Hello, this video is going to go through some examples of solving linear inequalities. So our first question says solve x minus 6 is greater than 0. And when we're solving inequalities, we're going to be finding a solution set as opposed to just a specific value for the solution. So in other words, there's going to be a whole set of values for x that will work to satisfy this inequality or to make this inequality true. So when we solve inequalities that are linear inequalities, we can use the same kind of opposite operations that we would normally use for solving linear equations. So here, for example, I have x minus 6 on the left side. I can add 6 to both sides of this inequality to get x minus 6 plus 6 on the left, and then 0 plus 6 on the right. And on the left, that means negative 6 plus 6 gives me 0, so I'm left with just x. And on the right, I have 0 plus 6, which is 6. So my solution to this inequality is x is greater than 6. And I can write that solution set using either set notation, so x is any real number such that x is a number greater than 6, so not including 6, just greater than 6. Or I can write the solution set in interval notation. So x can be any value greater than 6. So we would say starting at 6, but not including 6. So we use an open bracket up to infinity. Here's a second example. Solve negative 2x plus 5 is less than 0. So again, it's a linear inequality. We could start by subtracting 5 from both sides. So we get negative 2x plus 5 minus 5 is less than 0 minus 5. So we subtracted 5 on both sides. To get negative 2x is less than negative 5. Now here's the exception with using opposite operations to solve inequalities. If this was an equation, like negative 2x equals negative 5, then our next step would be to divide both sides by negative 2. With an inequality, that's not going to work. If we divide both sides by negative 2, our inequality sign needs to switch in order to maintain a true statement. Okay? So for example, if we have the inequality 3 is less than 8, and if I divide both sides by a negative value, let's say divide both sides by negative 1. If I divide both sides by negative 1, I have negative 3 is less than negative 8. And that's no longer a true statement because negative 3 is actually a bigger number than negative 8. Okay? Or again, if I start with the inequality 3 is less than 8, and I multiply by a negative number. So if I multiply this inequality by a negative number, I get negative 6, let's say I multiply by negative 2, is less than 8 times negative 2 is negative 16. Well, again, negative 6 is actually greater than negative 16. So we need to, whenever we are multiplying both sides of an inequality or dividing both sides of an inequality by a negative number, we need to switch the sign or switch the direction of the inequality sign. Okay. So we'll do that here. So we're going to divide both sides by negative 2. But when we do that, we switch the inequality sign. So we get x is greater than, and then negative 5 divided by negative 2 is positive 5 over 2. So as soon as we divide both sides by negative 2, we have to switch the sign or switch the direction of the inequality sign. So if I take that back just a step, if we were to write in that extra step of dividing both sides by negative 2, again, if this were an equation, then we would usually write that step right here. We just say divide by negative 2, like this, divide by negative 2. But as soon as we do that, we have to switch the sign. So we can't really do that in this same step. We have to do that in a separate step. So if you're going to write out that division on both sides by negative 2, then we would have to write that out as a separate step. So divide the left side by -2, make sure I switch the sign now so that this is actually a true statement, and divide the right side by -2. And then I get, again, x is greater than positive 5 over 2. Again, we can write our solution set in either set notation or interval notation. In interval notation, this would be x is an element of all values starting from 5 over 2, but because this is strictly greater than, we're not going to include 5 over 2 up to infinity.